Snowflake is a cloud-based data platform that enables organizations to store, manage, and analyze data with high scalability and performance. It combines data warehousing, data lakes, and data sharing capabilities, making it a popular choice for businesses seeking flexibility and efficiency in handling large volumes of structured and semi-structured data. Because Snowflake is widely used in analytics, data engineering, and business intelligence, interviews for roles involving Snowflake often focus on architecture, SQL, performance optimization, security, and data modeling. Preparing for a Snowflake interview requires a strong understanding of its architecture, features, best practices, and practical experience with queries, data loading, and performance tuning. Employers look for candidates who can effectively design, implement, and manage Snowflake solutions while ensuring data integrity, security, and optimal performance. This video explores common Snowflake interview questions, provides sample answers, and shares tips to help you demonstrate your expertise. Question 1. What is Snowflake, and how is it different from traditional data warehouses? Answer begins here. Snowflake is a cloud-based data platform that supports data warehousing, data lakes, and data sharing. Unlike traditional data warehouses, Snowflake separates compute and storage, enabling scalable, concurrent access without resource contention. It also natively supports semi-structured data formats like JSON, Avro, and Parquet, making it flexible for modern data workloads. Tip: highlight scalability, cloud-native architecture, and support for diverse data formats. Question 2. Explain Snowflake's architecture. Answer begins here. Snowflake has a 3-layer architecture: database storage, query processing, compute, and cloud services. The storage layer handles persistent data storage, while the compute layer, using virtual warehouses, performs query execution independently. The cloud services layer manages metadata, security, query optimization, and coordination. This architecture allows elastic scaling and concurrent access without affecting performance. Tip: use diagrams if allowed, and emphasize separation of storage and compute. Question 3. What are virtual warehouses in Snowflake? Answer begins here. Virtual warehouses are independent compute clusters in Snowflake that process queries. They can scale up or down to handle workload demands and can run concurrently without interfering with each other. For example, running ETL processes on one warehouse won't impact buy reporting queries running on another warehouse. Tip: show understanding of workload isolation and elasticity. Question 4. How do you load data into Snowflake? Answer begins here. Data can be loaded into Snowflake using the copy command for bulk loading from cloud storage like AWS S3, Azure Blob, or Google Cloud Storage. Small or streaming data can be inserted using insert statements. Additionally, Snowflake supports Snowpipe for continuous, near real-time data ingestion. For example, I have used Snowpipe to automate ingestion of transactional logs from S3 into a Snowflake table for analytics. Tip: mention both batch and continuous loading methods. Question 5. How do you optimize performance in Snowflake? Answer begins here. Performance optimization includes selecting appropriate virtual warehouse sizes, clustering large tables, using result caching, and optimizing queries with proper joins, filters, and partitions. For instance, I optimized a large customer dataset by clustering on frequently filtered columns, which improved query performance by 40%. Tip: emphasize both query level and architectural optimizations. Question 6. What are Snowflake's data sharing capabilities? Answer begins here. Snowflake allows secure and instant data sharing between accounts without physically copying data. This enables collaboration across business units or external partners while maintaining control over access. For example, I shared product analytics data with a vendor account using secure data shares, eliminating the need for manual CSV exports. Tip: highlight security, simplicity, and collaboration benefits. Question 7. Explain the difference between transient and permanent tables in Snowflake. Answer begins here. Permanent tables are standard tables with full-time retention and fail-safe support. Transient tables are temporary, lack fail-safe, and are used for intermediate data or staging environments to reduce storage costs. For example, I often use transient tables to stage data before ETL processing, minimizing storage overhead while ensuring temporary data is available for transformations. Tip: show awareness of table types and use cases. Question 8. How does Snowflake handle semi-structured data? Answer begins here. Snowflake supports semi-structured data formats like JSON, Avro, ORC, and Parquet using the variant data type. It allows querying nested data using dot notation and functions like flatten. For example, I have queried JSON API responses stored in variant columns to extract nested user information without pre-transforming the data. Tip: emphasize native support and flexible querying of semi-structured data. Question 9. How do you ensure data security in Snowflake? Answer begins here. Snowflake provides end-to-end encryption, role-based access control, RBAC, multi-factor authentication, and network policies. I usually implement RBAC by granting roles to users and applying the principle of least privilege. For example, analysts had read-only access to sensitive tables, while ETL developers had write access only to staging areas. Tip: show knowledge of security best practices and compliance. Question 10. What is the difference between clustering and partitioning in Snowflake? Answer begins here. Snowflake does not use traditional partitioning but offers clustering keys to organize large tables based on columns frequently used in filters. Clustering helps improve query performance without manual partitions. For example, clustering a sales table by date enabled faster range queries for monthly reports. Tip: highlight performance optimization for large datasets. Question 11. How do you monitor Snowflake usage and costs? Answer begins here. I monitor usage using the account_usage schema, which provides queries, warehouse activity, and storage consumption. I also schedule auto-suspend for virtual warehouses and adjust sizes to control costs. For example, optimizing warehouse sizes and suspending idle clusters helped reduce monthly compute costs by 20%. Tip: show both monitoring and cost control strategies. Question 12. Explain Snowflake's time travel feature. Answer begins here. Time travel allows querying and restoring historical data within a defined retention period, up to 90 days for enterprise accounts. It helps recover accidentally deleted or modified data. For example, I restored a mistakenly truncated table using time travel, avoiding data loss and saving hours of reprocessing. Tip: highlight data recovery and auditing benefits. Question 13. What is Snowpipe, and when would you use it? Answer begins here. Snowpipe is Snowflake's continuous data ingestion service that loads data automatically from cloud storage as soon as files are available. It's ideal for near real-time pipelines, such as streaming transactional data. For instance, I used Snowpipe to ingest daily sales logs from S3 into Snowflake for timely reporting. Tip: emphasize automation and near real-time processing. Question 14. How do you handle schema changes in Snowflake? Answer begins here. Snowflake allows adding or modifying columns without downtime. I typically use alter table commands to add new columns or modify column types. For major changes, I test on a clone of the table first to avoid disrupting production queries. For example, adding a new attribute to a customer table was done seamlessly without affecting reporting pipelines. Tip: highlight flexibility and risk management in schema evolution. Question 15. Why should we hire you as our Snowflake specialist? Answer begins here. You should hire me because I bring hands-on experience with Snowflake architecture, data modeling, ETL processes, and performance optimization. I have successfully implemented scalable data pipelines, ensured data security, and improved query efficiency in cloud environments. My expertise will help your organization leverage Snowflake to drive data-driven insights effectively. Tip: emphasize practical experience, problem-solving skills, and measurable results. Closing thoughts. Snowflake interviews evaluate both technical proficiency and practical experience with cloud data platforms. Employers look for candidates who understand Snowflake's architecture, can optimize performance, handle semi-structured data, maintain security, and implement scalable solutions. By preparing for these questions with real-world examples, structured answers, and knowledge of best practices, you can demonstrate expertise and confidence in using Snowflake effectively. Focus on demonstrating your ability to design efficient data solutions, troubleshoot challenges, and leverage Snowflake features for business value. With preparation and clarity, you can show interviewers that you are capable of managing their cloud data platform to deliver reliable, scalable, and actionable insights.